Yeah, good evening, children.
Good evening.
Online children. Good evening.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children. I've shared my screen. Visible to all of you?
Yes, ma'am.
Yes, ma'am.
Yeah, very good. See you. Okay. We're taking up a question similar to the ninth question, which we discussed in the last class. If sine theta plus sine square theta is equal to 1, find cos theta to the power 12 plus 3 cos theta to the power 10 plus 3 cos theta to the power 8 plus cos theta to the power 6 plus 2 cos theta to the power 4 plus cos square theta minus 2. So it's given that sine theta plus sine square theta is equal to 1. Transpose. So sine theta is equal to 1 minus sine square theta. So sine theta is equal to cos square theta. Cos square theta. We have this result. Now 1, 2, 3, 4, 5, 6, 7 terms. The last 3 terms have 2 in common. So we'll have them as one group. The first 4 terms, in the first 4 terms, you can see 3 terms which have 3 as a coefficient. So this makes us consider the identity a cubed plus 3a square b plus 3ab square plus b cubed. Because see, it matches exactly, right? 4 terms, a cubed, 3a square b, 3ab square, b cubed. So here also we have 4 terms. And of these 4 terms, these 2 terms have 3 in them, right? So we're trying to relate that identity with the first 4 terms here. So cos theta to the power 12. I'll just write out the 4 terms. Cos theta to the power 12, 3 cos theta to the power 10, 3 cos theta to the power 8, and cos theta to the power 6. So this is the a cubed term, and this is the b cubed term. So this is 3. So 3 into 4 is 12. So cos theta to the power 4. 4 3s are 12. And here cos theta to the power 2. 2 3s are 6. So this is A, and this is B. So 3a square B, 3a square cos theta to the power 4, a square into B, cos square theta. Correct? And 3ab square, A is this one, cos theta to the power 4, a B square. This is B and square. This is A, this is A, this is B. So 3a square B, 3ab square. Now let's check if this works to 3 cos theta to the power 10 and this one works to 3 cos theta to the power 8. So how do you simplify this? 4 2s are 8. So cos theta to the power 8 into cos square theta. Bases are same, multiplication, add the powers. So 8 plus 2, 10. So here we have 3 cos theta to the power 10. And here 2 into 2, 4. Bases are same, cos theta, add the powers. 4 plus 4, 8. So cos theta to the power 8, 3 cos theta to the power 8. All right. So this makes what these 4 terms make a plus b the whole cube. We have a cube, 3a square, a cube plus 3a square b plus 3ab square plus b cube. It's a plus b the whole cube. All right. So this is a. This is a plus this is b the whole cube. Correct? A plus b the whole cube. So here you have a plus b. Here, a plus b the whole cube. And the last 3 terms, the last three terms have 2 in common, right? The last three terms have 2 in common. So I've taken out 2 common. Okay, now here, because the identities have power 2, we are fine with the power 2. We don't want power 4. We don't want, careful, we don't want power 4. So wherever the power is 4, we write it as cos square theta. Yeah. So wherever it is power 4, we write it as 2 into 2. Okay, so power 4, so 2 into 2, power 4, 2 into 2, right? See, this is a plus b the whole cube, children. After taking 2 common, we have this in the bracket. Now this is power 4, this is power 4. We don't disturb the others. This power 4 is written as cos square theta the whole square. Here also power 4, so cos square theta the whole square. Now we have this result. Now what is cos square theta? Sin theta. And I've told you, this cos square theta, don't write sin theta. This cos square theta is sin theta. So sin theta the whole square is sin square theta. Right? And here also this cos square theta is sin theta, and sin theta the whole square is sin square theta. So we have sin square theta plus cos square theta the whole cube. So 1 cube. And here sin square theta plus cos square theta is 1. 1 minus 1 is 0. 2 into 0 is 0. So the answer is 1. Since, you know, like you're busy with tests, slip tests, what if cycle tests at school, today I'll finish the last part of trigonometry, and I'll give you time to practice trigonometry, because next week, last class, most of you said you have a test next week. So I don't think you will take the time out to complete the notes. So next week is gone. Then after that, if we start off with something else, then this will just be left behind. So I just want you to practice as much possible in today's session. All right. So this will work, and if you have further questions, you can ask me. I just made it roughly because we have understood a similar question in the last class. Okay. So, see this one. Given that 1 plus cos alpha into 1 plus cos beta into 1 plus cos gamma is equal to 1 minus cos alpha into 1 minus cos beta into 1 minus cos gamma, show that one of the values of each member of this equality is sin alpha, sin beta, sin gamma. Show that one of the values of each member of this equality is sin alpha, sin beta, sin gamma. I'll explain. We'll see the answer, and then I'll explain what this part of the question means. Okay. Now, okay, equality is what equation? Now, who are the members of this equation, the left-hand side and the right-hand side? Left-hand side and right-hand side. Show that one of the values, so that means there can be other values. You should show that one of the values of each member of this equality. This is one member. This is one member of the equality. This is the other member of the equality. You must show that each member of this equality, show that one of the values of each member of this equality is this one. So that means there can be other values. See, the equality is this whole equation. Okay, this equation is the equality. And the members are the left-hand side and the right-hand side. You must show that the value of the LHS, you must show that the value of this member is this. There can be other values. Of those many values, one of the values is this. You should also show that one of the values of this member is also this one. Show that one of the values of each member of this equality is this one. So you must show that the value of this member is this, and the value of this member is also this. This is actually pretty simple. It just looks like too much. Very easy to understand. So now what we do is we multiply. So this equality is given. See, it's given. This equality is given to you. You don't have to prove this. That's given. So take up that equality or that equation. Now, here we are multiplying both the sides with 1 minus cos alpha into 1 minus cos beta into 1 minus cos gamma. That is, we are multiplying both the sides with the RHS. Here we are multiplying both the sides with the LHS. Multiplying both the sides with 1 plus cos alpha, 1 plus cos beta, 1 plus cos gamma. When you do this, you will get the result. That's it. See, write the equation given. This is the equation given. Okay. You can do anything first. So first multiply both the sides of this equation with this part. Then multiply both the sides of the equation with this one. You can do anything first. Anything first you can do. All right. Okay. So multiplying both the sides with what have I done here? This one. See, 1 minus cos alpha into 1 minus cos beta into 1 minus cos gamma, we get. Okay, we get. What do you get? Multiply this one. So 1 plus, see, 1, 2, 3 expressions are already there. You will have to multiply that with this, and this, no? So when you write this one, and it's, like it's counterpart kind of. This one, both these two together, these two together, and these two together. You have to multiply, right? So this one into this one into this one, and this one into this one is equal to, multiply the RHS also. RHS, so it will be 1 minus cos alpha into 1 minus cos alpha. 1 minus cos beta into 1 minus cos beta. 1 minus cos gamma into 1 minus cos gamma. See here. Now on the left hand side, it's like a plus b into a minus b. This is a plus b into a minus b. This is a plus b into a minus b. This is a plus b into a minus b. On the so the result will be a squared minus b squared, a squared minus b squared, a squared minus b squared. RHS, it is 1 minus cos alpha into 1 minus cos alpha. So 1 minus cos alpha whole square. 1 minus cos beta into 1 minus cos beta. 1 minus cos beta whole square. 1 minus cos gamma, 1 minus cos gamma. 1 minus cos gamma, the whole square. So this one, so this a square, b square, c square can be written as abc the whole square. A square, b square, c square can be written as abc the whole square. That's what in the next step. 1 minus cos alpha into 1 minus cos beta into 1 minus cos gamma, the whole square in the next step. What's happening on the left hand side? Left hand side, this one by the identity signs for alpha. Identity signs for beta. Identity signs for gamma. So this can be, this again is like a square, b square, c square, which can be written as abc the whole square. So sine alpha, sine beta, sine gamma whole square. So on both the sides, we have perfect squares. It's like we have x squared is equal to y squared. Therefore, x is equal to 1. Here, you see, this is a perfect square. Can you see this? See, this one also is a perfect square. So like the squares get cancelled. And we have 1 minus cos alpha into 1 minus cos beta into 1 minus cos gamma is equal to sine alpha, sine beta, sine gamma. See, we have proved that this member of the equality, this member, the right hand side member of this equality is equal to sine alpha, sine beta, sine gamma. All right. Just see if try to understand this yourself. This is the equation given. Went through? Went through, children? Yeah. So when you multiply both the sides with this one side becomes a plus b into a minus b. The other side becomes a plus b into a plus b. One side becomes a plus b into a minus b. The other side becomes a plus b into a plus b. So a plus b into a plus b means a plus b the whole square. A plus b into a minus b is a squared minus b squared. Then you must write both the sides as a perfect square. So here you get, these are three different perfect squares like a square, b square, c square. So you write it as a into b into c the whole square. And here this is sine square alpha, the sine square beta and sine square gamma. So write it as sine alpha, sine beta, sine gamma whole square. So now the squares on either sides gets cancelled. And so we have 1 plus cos alpha into 1 plus cos beta into 1 plus cos gamma is equal to sine alpha, sine beta, sine gamma. So we proved that the other member of this equality, the other member, this is the other member of the equality, is also equal to sine alpha, sine beta, sine gamma. Right? One more question like this and we are done with trigonometry. Yeah, go through this similar to the earlier one. Yeah, sure. What finger magic you're doing? Understood this one? Went through this one? Okay. Okay. So here also prove that each side is equal to plus or minus 1. So a multiple. So I've started with multiplying both the sides with this one. Multiplying both the sides with the right hand side. So when you do that, it is secant A plus tan A into secant A minus tan. Okay, I've written it like this. Okay, secant A plus tan A into secant A minus tan A. Secant B plus tan B into secant B minus tan B. Then secant C plus tan C into secant C minus tan C, right? Yeah. So here on the other side, we'll have secant A minus tan A into secant A minus tan A. Secant A minus tan A the whole square. Secant B minus tan B into secant B minus tan B. Secant B minus tan B the whole square. Similarly, secant C minus tan C the whole square. So here, secant A plus tan A into secant A minus tan A. A plus B into A minus B is A squared minus B squared. So this into this is secant square A minus tan square A. Secant square B into tan square B. A plus B into A minus B. A squared minus B squared. Secant square C into secant square C minus tan square C. Secant square C minus tan square C. And we know secant square A minus tan square A is 1. Secant square B into tan square B is 1. Secant square C into tan square C is 1. Identity. See, secant square A minus tan square B is not 1. The angle should be the same. Secant square A minus tan square A is 1. Secant square B minus tan square B is 1. Secant square C minus tan square C is 1. So 1 into 1 into 1 is 1. And here, this is like A square, B square, C square, which can be written as A into B into C the whole square. So secant A minus tan A into secant B minus tan B into secant C minus tan C is equal to the square here on the other side plus or minus square root of 1. Like you have A square is equal to 1. So A is equal to plus or minus square root of 1, which is plus or minus 1. Correct? Again, take up the equality given. We've multiplied here with the RHS. So here multiply both the sides with the LHS, this one. Multiply both the sides with the LHS. So this into this, multiplying both the sides with the LHS. So this into this, this into this, this into this. Now this into this, this into this is here, this into this is here. Here I've written the results straight away. I should have written actually all the 6 expressions. I was not mistake. I should have written this into this. Oh, I should have presented that this into. Oh my God. Okay, this into this, this into this, this into this. All the 6 expression I should have shown here. Okay, I'll just change this later. So here it is like A minus B into A plus B, A squared minus B squared. A minus B into A plus B, A squared minus B squared. A minus B into A plus B, A squared minus B squared. Now all this is 1. All this is 1. So 1 into 1 into 1 is 1. Here you can write this as this into this into this, the whole square. Like take away the squares from here. It will be this into this into this, the whole square is equal to 1. So the square on the other side will become plus or minus square root of 1, which is plus or minus 1. All right. Yeah. So with this, we conclude the chapter trigonometry.